Okay. We're going to talk about isomers next. So section 24.4. There are isomers that occur for these complexes, and isomers typically are known as same formula, different structure. It turns out there are two types of isomers here, two broad categories. These subcategories here are divided into structural isomers and stereoisomers. Structural isomers, there are different types of structural isomers, but all of them share something in common. All structural isomers are going to have a different bonding arrangement or different skeleton. And so an example of structural isomers would be C2H6O. C2H6O could be ethanol or it could be ether. You know, and the properties and structures of those are totally different, ethanol versus ether. And so for structural isomers, they further subdivide it into different categories, but we aren't going to worry about it. For example, ionization isomers. Here we have a chromium sulfate bond, whereas over here we have a chromium chloride or chloro bond. And so the counter ion would be chloride here, it would be an ionic bond here, the counter ion sulfate. And so even though atom-wise these are the same, structurally these are different. So this would be an example of a structural isomer, a chromium sulfate bond versus a chromium chlorine bond here. But it's made up of the same stuff. A coordination isomer would be an example of a structural isomer as well, because here we have cobalt bonded to the amine. Here we have chromiums bonded to the amine. Chromiums are bonded to the cyanos. Cobalt's bonded to the cyanos. So we just swap the ligands. You swap the ligands, you're going to get a totally different structure, right? Totally different skeleton. There's a structural isomer as well, because the bonds are different. The bonds are different here. The bonds are different here. Linkage isomer is another example of a structural isomer. Here we have cobalt bonded to the nitrogen of the nitrite or nitrito. So this would be nitrito N. Over here we have cobalt bonded to the oxygen of the nitrite. And so this would be nitrito O. Same formula, just different bonding. And so again, structural isomer. A cobalt nitrogen bond versus a cobalt oxygen bond here. Stereoisomers are different. Stereoisomers are going to show the same bonds. And so all the bonds are the same. So if you look at it, oh, cobalt chlorine, yes, cobalt chlorine. Cobalt bromine, cobalt bromine. All the bonds are the same. The only difference is their three-dimensional arrangement. And so stereoisomers, there are going to be two types of stereoisomers that we're going to deal with. There are going to be geometric isomers. And so let's take a look. There are four types of geometric isomers. Two of them are shown here. So when we look at it, this is platinum. Platinum, two platinum chlorine bonds, two platinum chlorine bonds, two platinum amine bonds, two platinum amine bonds to the nitrogen. And so the exact same bonds. So these aren't structural isomers. The only difference is their arrangement in three-dimensional space. When we look at this one, this has the two chloros adjacent to each other. And so when they're adjacent, we call it cis, or C. And so the two amines are adjacent to each other, forms a kind of a C here, or a B. And so that's cis isomer. The trans isomer, we have the chloros opposite each other. And so here the chloros are 180, here the amines are 180. Here they're adjacent at 90. And so cis trans just means adjacent, opposite. all the bonds are the same. It's a stereoisomer, and specifically this is a geometric isomer, cis-trans geometric isomer. That's it when you have two of a kind. Okay, here in an octahedral complex we can see it again. Two of a kind. The chloros are adjacent, that's the cis. The chloros are opposite, that's the trans. When you have three of a kind, and then we have the face isomer, FAC. FAC, this stands for face of a octahedron, or the facial isomer. In other words, if we look at an octahedron, there's 8 sides to this polygon, and so on one of the sides we have chlorines at all the corners here. And so that can be compared to this one. This one would be the mirror isomer. So three of a kind, rather than putting it on the face of the polygon, we put it on the edge of the polygon, or the meridian of the polygon. And so we get the mirror isomer. If we look at it, we have a mirror arrangement of the chloros and of the means. Both are on the edges. Up here we have a facial arrangement of the chloros and a facial arrangement of the amines. And so for geometric isomers, all the bonds are the same. It's just a difference in three-dimensional space. So you could have cis, trans, or mirror, face. Those are the 4 possibilities. And so let's try this out. And what helps is to build models of these sometimes so that you can better visualize it. And so what we're going to do is I'm going to have you check out some model kits, and then you're going to build just one.
Wait, so what does the mirror look like again? Is that one?
Well, this is called octahedral geometry because if you connect all the vertices, it forms an octahedron, right? 8-faced polygon. And so the mirror would just be, if you look at one of the faces of the polygon, you have an atom at each corner. That would be the face. Sorry. The mirror is an atom along the meridian or the edge of the polygon. And so this would be the mirror isomer. This would be the face isomer. So it just depends on what you do with the third atom. Put it here or put it there. So the mirror. Mirror just means along the meridian. All right, so you're going to check out a model kit, and then you're going to tell me all the isomers that you can come up with for this. It's going to be platinum. It's going to be a square planar complex. And so we're going to go platinum with the chloro ligand here, a bromo ligand here, an iodo ligand here, and a fluoro ligand here. And tell me all the isomers that you can come up with for this. Okay. And so go ahead and check out a model kit, 1 kit per person, and give you a little time to figure this one out.